everybody, welcome back to day 2 of probability. Today we're going to talk about conditional probability and two-way tables. In our first video we talked about basic probability and pretty basic two-way tables. Today we're going to get into a little bit more complicated two-way tables and work with those, as well as working with something we call conditional probability. So people get confused a lot when it comes to probability, and especially when we start talking about things like conditional probability. Well, so what does condition mean? And just think about what conditions mean in your own world. You're faced with conditions all the time, right? So think about, you may want to go to a party this weekend, but your parents put a condition on you that you can only go out if you're passing all your classes. So if you're passing your classes, then you can go to the party. The passing your classes, that would be a condition. And probability is really no different. So with conditional probability, we're limiting the scope of the probability problem to only those things that meet the condition. The definition of conditional probability is that the probability that one event happens given that, and those are important words, given that another event is already known to have happened. So suppose that we know that event A has already happened, the probability that event B happens given that event A has already happened is denoted as the probability of B given A. So you see this notation with the capital P and then parentheses event B given A. So this vertical line here, this is what shows up a lot in the probability problems. This vertical line is what means given that. Example number 1. We have a two-way table that is giving us information along with a prompt here. So always read the prompt. Don't skip over that. I know students like to skip over the words. So let's read that. So invitations were sent to 144 students to attend a party this Saturday night. The following data table summarizes the number of people who will attend the party and if they're passing all of their classes in school. So this goes back to the whole conditional situation, right? You can only go to the party if you're passing all of your classes. Well, life's not fair. So some people's parents will let them go to the party even if they're not passing all their classes, and that's just life. So if you remember from our last video, what is our strategy for attacking these types of problems? Right. You always want to add the totals. So don't forget to do that. You want to add a row for your totals and a column over here to the right with the totals. And then go ahead and add up the number of people who will attend the party, who will not attend the party, and who are passing their classes and not passing their classes. So now we're all set up to attack this problem. So first let's do a little review. So let's figure out the probability of reaching into a box. Remember, we said a way to think about these problems is throw all of these students into a big box in your head. Of course, not in reality. In your head, shake up the box and then reach in, pick out one student. What's the probability that that one student you reached in and pulled out of the box will attend the party? So to do that, we want to look at the total number who plan to attend. So we have 96 people who said that they will attend the party out of 144. If we simplify that as a fraction, that would be 2/3, and then we can round that off as a decimal answer as 0.67. So about 67% of the people who received an invitation will attend the party. And then part B is, what is the probability that we reach into the box? We put that other person back, assuming we're starting over on all these problems. So Put all the people back in the box, 144 people back in the box, shake up the box, reach in, pick out one student. What is the probability that that one student is passing all of their classes? So now we're just looking at passing. So we just want to look at the total over here of the students who are passing their classes out of the 144 people who received an invitation. So that is 100 out of 144, simplifies to 25 over 36, or about 0.69, or 69% of all of the students who received an invitation are passing their classes in school. So now let's look at part C. So C is a little bit different because this is where we're placing a condition on the probability problem. So part C, what is the probability that a randomly selected student will attend given that they are passing classes? So now we're just looking at the probability that they'll attend given that they are passing their classes. So we have to just look at only the passing column. And now our total that we're considering is out of 100 students, not 144 students, because only 100 of them are passing. So to calculate the probability that we randomly select a student who is attending the party given that they're passing, that would be 85 out of 100. So let's go on to part D now. So part D is also conditional. So now what is the probability that a randomly selected student is not passing their classes given that they will not attend the party? So here we go with our given that again. So this is also conditional. And so we're going to look at not passing classes given that they will not attend. So in this case, I'm only looking at the group over here that will not attend. This is my condition, is that I'm told that these students will not attend the party. So my total that I'm working out of now is not 144 students. It's only the 48 students who will not attend the party. And then I'm interested in the, out of that group, what proportion of those students are not passing their classes. So now I'm looking at just this group, right, who's not passing their classes. So not passing, they're in this column of not passing. So 33 out of the 48 students are not passing their classes given that they will not attend the party. So 33 divided by 48, that simplifies to 11 out of 16, and that's about 0.69, or about 69% of the students. So if I reach in and pick out a student at random, the probability is 33 out of 48 that I would choose a student who is not passing classes given that they said that they will not attend the party. So now we've discussed conditional probability, but it can get a little bit confusing with the wording of questions. So let's go on and look at question E. So of the people who will attend the party, what proportion are not passing their classes? So in this problem, this is still a conditional problem. Of the people, that's putting the condition, if you see these words like out of the people who will attend. So of the people who will attend, what proportion are not passing their classes? So even though we don't have the actual words given that, it's still a conditional probability problem. And so we're only looking at the people, the group of people who will attend the party. So out of that group of who will attend the party, out of the 96 people who will attend, what proportion are not passing? So we would get 11 out of 96, or about 11.11%. And then on to part F. So if you randomly select a person who is passing their classes, what is the probability he or she will not attend? So again, we're putting a condition on this. So we're saying the person who is passing their classes. So that's our condition, that's our given that. And so that becomes our total. So now we're only looking at the total number of people who are passing, which is 100. So the people that will not attend, we have 15 of them out of 100, so we get 0.15 or 15%. And then don't get confused with the problems we did earlier on day 1, like in G and H. So compare what we've just done to these problems. On part G, the person will attend the party and is passing their classes. So this is not a conditional problem. This is just a regular probability problem with the and. So remember, and is exclusive. So they have to have both things. They have to be attending the party and passing their classes. So in this case, you're looking for the intersection of attend and passing, which is up here. And then there's no condition, so you're talking about out of all the people who were invited, so out of 144 people. So will attend and passing would be 85 out of 144, or about 0.59. And then lastly, H, the person that will attend the party or is passing their classes. And remember when we talked about or is very inclusive. And remember, with or problems, you want to think in your head this and or that. So if they will attend the party, so we have these 96 people who will attend the party, so 85 who are passing, 11 are not passing. That covers this part, attend the party, or they are passing their classes. So we also need to include these 15 people who are passing their classes who will not attend the party. And you want to add up your 85 plus 15 plus 11, which gives us 111 out of 144 students. So about 77% of all of the students are either going to go to the party or are passing their classes. So example 2, and we'll run through this kind of quickly, but sometimes you might see tables that are more complicated. They have a lot more rows and a lot more columns, and sometimes the probability questions are asking you to group categories together. So let's look at 2 of these types of problems really quickly here. So in this problem, we gave a school survey and students were asked about their favorite show to binge watch during the stay-at-home order. So the following table shows the results of the survey here. So we have all of these shows over here with BoJack Horseman, Criminal Minds, Gilmore Girls, Peaky Blinders, and Stranger Things. And then the students are grouped as either freshmen, sophomore, juniors, or seniors. And I've gone ahead and entered the totals here. If you didn't have totals, of course, you would do that first. So in the first question, part A, what is the probability that we select a student who is a freshman or a sophomore given that they watch Stranger Things? So we have this or problem here and a conditional probability problem because we have that given that they watch Stranger Things. So when we approach this problem, we could write it like this: the probability of freshman or sophomore given Stranger Things. So remember, Stranger Things is going to be our denominator here. So we're only looking at the total based on the students who have replied that they prefer to watch Stranger Things. And so out of that total of 180 people who prefer Stranger Things, 45 plus 50, that gives us 95 students are either a freshman or a sophomore, given that they watch Stranger Things. So about 0.53 or 53%. And then part B, what is the probability that the randomly selected student we select prefers Peaky Blinders, given that they are a freshman or a sophomore. Well, this one looks a little bit more complicated because we want to know if they're a freshman or a sophomore. So this Peaky Blinders of the freshmen, so there's 50 freshmen who like Peaky Blinders and 15 sophomores who like Peaky Blinders. So given that they are a freshman or a sophomore, we need to use our total. We're going to have to combine these two numbers, 175 plus 150, to get our total. So we can write it like this: Peaky Blinders given freshman or sophomore, and then we add up 50 plus 15 to get 65, all over 175 plus 150, which is 325, and that works out to be 0.2 or 20%. So when you have these complicated tables, just break the problem into pieces and you can combine categories in order to get the totals and the pieces that you need to work with. So thanks for joining in today, and look for the next video where we'll talk about compound probability problems, which include multiplying events and taking into consideration events that have words like with replacement, without replacement, and we talk a little bit more about conditional probability in those cases as well. Have a great day. Bye-bye.